This is number 8 from the week 13 problems. So we're trying to solve this triangle, and solving the triangle means we're finding all the sides and all the angles. So if I've got angle A down here that I know is 61.4 degrees, then that means side A is going to be across from that angle. And these ones, don't try to draw them as right triangles because they won't. That's what this whole unit is about, is triangles that aren't right triangles. So I'm just going to make side A over here, this side B, and that means that this is going to be angle B over here. A couple things to remember is that we can't do the Pythagorean theorem because this isn't a right triangle. So even though we know 2 of the sides, that doesn't mean that we can get the third side that way. We're either going to do the law of sines or the law of cosines. And for this one, because we've got this angle and the side across from it, we can do the law of sines. And that just says that the side length and the sine of the angle are proportional for all the angles in the triangle. So we could do A over sine of A equals B over sine of B. Because we know side B, what we don't know is angle B. If we knew that angle, then we could get the third angle, and then we could do something else to get the third side. So now I'm going to fill in my numbers. And what I want to do is take this and solve it for the sine of B. And this is just a rational equation that I can cross multiply. So I'm going to do 35.5 times the sine of B equals 39.2 times the sine of 61.4. And then I want to solve for sine of B, so now I'm going to divide those sides by the 35.5. Okay, and when I'm doing these, I usually just go ahead and write it out like this, and I put it all in my calculator at once. That way I don't have to worry about rounding. Oh, and I make sure my calculator's in degree mode. It's not, so now I can do the sine of 61.4. And with this, I just have to make sure and close the parentheses for the sine before I do the division part. The sine of B is something like that. And now what I can do is I can use my inverse sine to actually find the B. So if I do the inverse sine of this value that I just got, that's going to get angle B. And the way I'm going to do this on the calculator, since I already have the number here, I'm going to do inverse sine, and then I'm going to tell it to take that answer, which I'm going to use second and the negative key down here, where it says ANS at the top. Okay. That will give me back the last answer that I had. And this is one of those where it would be possible to have either just one triangle or 2 triangles or no triangles. It could have turned out to be something impossible. That would have been if the sine of B would have turned out to be something greater than 1. So if this had turned out to be something like 1.2, that's not possible because the highest sine can go is 1. So in that case, it would have been no solution or no triangles possible. Since we did get an angle here, that means we either have 1 triangle or 2 triangles, and we need to figure out which one of those 2 situations we have. The way I drew this up here, side A was going out this way, but it's also possible that we could have another triangle. So it's possible that the A, instead of swinging this way, it could be coming back this way like this. If that happens, then we would have two possible triangles. We'd have this one the way I drew it originally, and we'd have this one. So we need to check and see whether this triangle is possible or not. The B turned out to be 75.8, but the reason that it's possible to have two triangles is that for this, we solved and got a first quadrant angle, so we got something less than 90 degrees. If we had a second triangle like this, our B would be something greater than 90 degrees. But if you have an angle greater than 90 degrees, it still has a positive value for the sine. So this could be possible. We just have to check and see whether it is or not. To do that, we want to look at what the supplementary angle for this would be. We're just going to call this B, and let's call it B prime. Would be 180 degrees minus 75.8. In that case, we'd have 104.2 for that angle. And what we want to do is see if that would be possible in this triangle. So if we had 104.2 here and 61.4 degrees here, would it be possible to have a third angle that would be small like this? So the question is whether these two add up to less than or more than 180 degrees. So if we take our A, which is 61.4, plus the 104.2, that gives us 165.6. Since this is less than 180, that means that, yes, we have a third angle in our triangle to make the three add up to 180. So we could figure out what that would be since we've got this info already. 0.6. Okay, so that would mean the third angle in this triangle would be C prime, which would be 14.4 degrees. So what we're doing is figuring out the angles for this triangle. So we have 104.2. Our angle C would be 14.4 degrees. So there's our second triangle. Our first triangle we'd have B would be 75.8. And then we could figure out the C for that one. So if we take 61.4 and 75.8, and then if we subtract that from 180, that's going to give us our third angle in that triangle. Okay, so that gives us our third angle up here, which would be 42.8 degrees. So that's the one thing we would still have to do would be to figure out side C for each of the two triangles. Right. So for that, we could go back to our law of sines again. And I would use the measures that we were given and not the ones we calculated. So I would do A over sine of A equals C over sine of C to figure out side C. So we know in this triangle, we know these three things, and we'd be trying to find that one. And then we'd have to do the same thing with this triangle. So also here we do A over sine of A equals C over sine of C. Only this time, for this one, our C is 14.4 degrees. In this one, it was 42.8. So these ones where it ends up being two triangles, they end up being a lot of work because you actually have to solve both triangles. Okay, so if we're using this, let's do it with this triangle to solve for side C, which is over here. So our side A is 35.5. And then we've got the sine of 61.4 equals side C, which is the thing we don't know, over the sine of angle C, which in this triangle is 42.8. So all of these with the law of sines, you always end up with a proportional equation like this where you can cross multiply. We're going to cross multiply these two. So 35.5 times the sine of 42.8 equals C times the sine of 61.4. And then since we're trying to solve for this, we're going to divide both sides by the sine of 64. And then you just plug that all in your calculator.